this video we are gonna learn about work, energy, theorem, derivation. So let's see what is that work, energy, theorem, derivation. So now first we have to assume certain constants like acceleration, force, mass, initial velocity and final velocity. We have to represent these with a variable, right? So let's assume force equal to F, acceleration is equal to A, initial velocity equal to U, final velocity V, distance S. So we have assumed these terms as variables, right? So now let's see this work, energy, theorem, derivation. As we know that work is equal to work done is equal to force into displacement. Right? So this can be written as W is equal to F into distance or displacement is the same, right? Displacement has direction and distance has no direction. That's the difference, but both are the same. So we have assumed the distance or displacement as S. So F into S, and force we have assumed it as F. So force is F. Okay. So now from relation V square is equal to U square plus 2AS. We have learned this equation, right? So V square is equal to U square plus 2AS. It's one of the law of motion. So now by this formula, let's find the displacement. So I am finding displacement. So I am sending all of it to this side. So it will be V square minus U square by 2A equal to S. Why? It's in positive sign, right? So it became negative, and it's in multiplication, so it became division. Okay. So we have got the value of S as V square minus U square by 2A. So now we have written an equation W is equal to F into S, right? So we already know that F is equal to mass into acceleration. We have learned it in our childhood that force is equal to mass into acceleration. So we have written an equation like work equation, right? Work is equal to force into displacement. Now in this we are gonna substitute the value of force as NA and the value of S as V square minus U square by 2A. Now let's see. Considering the equation W is equal to F into S. So substituting, now let's think this as equation 1 and this as equation 2. Like this as equation 1 and this as equation 2. So substituting the values in equation 1 and equation 2. So let's substitute. So W is equal to F into S, right? So W is equal to F into S, right? So let's substitute the value of F and S. So W is equal to, as we know, force is MA, and S we have found this value, right? So let's substitute it. V square minus U square by 2A. So if you observe, A and A can get cancelled. So W is equal to M into V square minus U square by 2. So this can be written as half M into V square minus U square, because half is there, right? So is equal to half M into V square minus U square, or we can write both V and U separately, right? Like W is equal to half mv square minus half mu square. This should be the order because V is the larger and U is the smaller one. So it should be mv square minus mu square only. Half mv square minus half mu square only. So we have got the derivation of the work energy theorem. Thank you.